Welcome back to the History of Automation podcast and show. My name is Shawn Tierney, and along with my co-hosts Jeremy and Gary, we'd like to ask you before we get into the show if you've been enjoying these episodes and if you think we should continue it in 2026. Now, it's quite a time investment every Sunday to meet with people and to recruit people and to interview them and then to edit and upload it. And so we want to make sure that if we're doing this, that there's an audience out there who wants to hear this every couple of weeks. And so we're asking you to place your votes. You go to givesendgo.com/automation museum, and you can make a donation like $5, $10, or $20 if you'd like to see us continue in 2026. And if we get no votes, that's okay too, right? Maybe the timing isn't right for an automation museum. But if you're enjoying the interviews we're doing with some of the legends in our industry about some of the products, the creation of some of the products that we all use and love on a daily basis, well then please consider going over to givesendgo.com/automation museum and help us raise enough funds to get this nonprofit off the ground. And either way, I want to wish you all good health and happiness. And now let's go ahead and get into this week's episode of The History of Automation.
Hey, everybody, welcome back to the History of Automation podcast from the Automation Museum. My name is Shawn Tierney, and I'm joined by a couple of great guys. First of all, we have our co-host Jeremy here. Jeremy, how you doing this week?
Doing so far so good. It's a little cold up here in the woolly north.
And we did hear from Gary. Unfortunately, he couldn't make it. But our guest this week is somebody you guys have probably heard of before and his company. Let me go ahead and ask John, our special guest, to introduce himself to the audience so they know who he is, and just tell them a little bit about what you do today and kind of how you get started in the industry.
Sure, thanks. Shawn, happy to be here. I've known Shawn and Jerry a long time. I'm John Weber. I'm the president and founder of a company called Software Toolbox that started out in 1996. Today, I lead a team of 23 and growing who are, I would say, have become known as one of the gold standards in industrial connectivity experts, providing a variety and portfolio of products for collecting data platforms, and feeding it to where it needs to go. A lot of you, if you've worked with us, you know us for our service and support. That's one of our big things is making sure you always get what you need. And look, we're growing, and I encourage you to watch us this year. Subscribe to us on LinkedIn. Marketing people require me to say that, Shawn. There's going to be some exciting stuff coming as early as the Prove It conference next month. If you're attending that, I look forward to seeing you there. We'll have a total of 5 of us there. So look, I got started in this industry in January 1990. Came out of school with an industrial systems engineering degree. I'd worked on computers, worked with Windows 2.0 in the late 80s. Got this cool job with a company called GE Fanuc that was a 3-year-old, cool, young, nimble joint venture in giant GE. And joined this technical sales and marketing program. And I show up in Charlottesville, and they do the HR stuff. And they said, "Oh, let me take you to meet your first manager." And they take me to tech support. And they introduced me to a guy named Larry Craig, who was the manager then. And I'm indebted to Larry and some other people like Stan Baker and Barry Fort that I want to say their names because none of you in this industry maybe have ever heard of them. But I tell you what, they've influenced a lot of people's lives because, boy, they taught a lot of people PLCs, technology. They taught me comms. My boot camp was Weber. Customers having a problem with this Series 6 talking to that Series 6 using CCM, blah, 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 over a multi-drop. Go in the lab, make a multi-drop serial cable, get it worked out, and then help the customer figure it out. Like the intro for a 23-year-old who took the job because they were the first person to have PC DOS-based programming software, not proprietary terminals. And I thought that was cool.
Mm-hmm.
Very cool.
I'd never seen a PLC in my life, guys. But it was a great learning experience. So that's how I got started. I'm sure along the way we'll talk about how Software Toolbox got started, but that's me.
Cool.
Yeah, it's very funny because how I got in the industry was I answered an ad that said needed somebody who knew for tech support, needed somebody who needed PLCs and PCs. And I told my wife, I know PCs. I've been using them since I was 11 years old. I don't know what this L is, but it's just an L. How different can it be? So, and I probably should explain, folks, I'm going to start putting all the legacy stuff up here in my old studio, which I used for 10 years. So I didn't say it at the beginning. I should have, but that's why the wall's empty, because I got, people have sent in PCMK cards and the old net alert meters and all kinds of stuff. So I wanted to say that. I also wanted to say before
Oh,
I
I've got
forget.
some stuff I'll send you if you want.
Well, thank you. As long as it's not like big, like MCCs or anything, I can't forget.
Yeah.
But I did also want to let the audience know that on my day job, we had John's company on, Software Toolbox, on the Automation Podcast. It was a phenomenal show. They told us about their product line, and they gave us a demo too. So those shows are always very popular with our audience over there at Insights. Today we're talking Automation Museum. This is nonprofit. So now that we got all those kind of housekeeping things out of the way, John, thank you for introducing yourself. And again, thank you for coming on today. We're in the middle of a snowstorm. There's a championship game going on right now. I told my family they had to record, they couldn't watch. But I did want to ask Jeremy to kick this off, because Jeremy had been in the industry 10 years before us. I got started in 1990 as well. And Jeremy, can you kind of set the foundation there? What were the things like in the 80s? And that kind of led up to this conversation we're going to have on OPC.
Sounds like a plan. And by the way, I started in 77.
Ah, okay.
So yes, I'm just that much older.
Logitrol, GE Logitrol PLCs back then.
Logitrol TI5s. There's a 590 in there somewhere. And of course the Rock, and I started with Alan Bradley. So the 1774 PLC was just sort of newly out. And Alan Bradley had developed this protocol called Data Highway, which allowed for connectivity between 1774 PLCs. And as the PLC family grew, the connectivity between all of these PLCs was Data Highway. With PLC2, I don't think the PLC4 had anything to do with communication as such. So it was just mainly the PLC2 and PLC3 that were Data Highway, and then the PLC5 came, and it changed to Data Highway Plus, and there's some technical differences, et cetera. But it was a way to share information from PLC to PLC, as well as to get information to HMIs and SCADA systems. And I know that General Motors wrote various drivers through a product called Interchange to access Data Highway and Data Highway Plus in order to get data into their VAX systems for predictive maintenance and for fault recording and alarm reporting, and on printers, no less, so that they can have their operators know exactly what the heck is going on. And as we discussed previously, the connectivity that happened, and anybody that needed to create that connectivity, such as Involution, such as Wonderware, et cetera, everybody had to create drivers. And so we had this guru bottleneck, if you will. I'll use Bill Leiden's mindset. That if you could develop a driver, well, you were close to God. And because we needed drivers to talk to everything, to get to the information up on an HMI screen or whatever, or to fire something out onto a printer. And there were 150 different drivers available in any sort of SCADA package, because of the fact that—
You wish.
Well,
I was over at GE, and I think we had 5, if that many.
Yeah. Well, I'm looking at, the Wonderwares and the Involutions of the world.
Oh, well, sure, yeah.
And in the DOS world, with overlays, creating a driver was just a pain. And when I started with Teledenkin Resources in 87, I guess it was, and they had all kinds of drivers for Modicon and for Alan Bradley for different PLCs and stuff, and for Data Highway and Data Highway Plus. Under DOS, it was so different. But when Windows came, everything changed because of the protected environment. And I'm not really quite sure where OLE or OLE came in. Fast EDE came in, communication stuff came in, then data started to come in. And the advent of the need to have the connectivity and data from disparate pieces of hardware created, in my estimation, the desire to have a common platform. Yes, sir.
No, I'm going to say I was there. I was excited
Yeah.
about Intelligent View. I was excited about RS View when we saw it at ICOM after Rockwell bought ICOM. They actually came in and demoed. We're in the middle of an ICOM class, and they demoed RS View, and it was great. And we hit the street in the mid '90s trying to sell it, and they're like, "We love it, but we have more than just Allen Bradley PLCs here.
Mm-hmm.
We have maybe have GE or Monicon or Siemens or whoever." And it was like a roadblock. It was like, we need help. We need drivers.
Yeah.
And so to me, from that side, I saw a need for something that everybody could use, that, a package like, I think in later years, we used a lot of Kepware or OPC driver suites that many companies make. And we needed something like that because they were eating our lunch, because every place we went, they said, great, that RS View. I love its animation. I love what you can do. But you only talk to Rockwell. How are you going to talk to all the other PLCs I have? And that was a real stumbling block in the early '90s for our, the HMI SCADA stuff we were trying to do. And that's where really Involution and Wonderware were eating our lunch.
Absolutely.
Yeah. They were eating our lunch at GE Fanuc also. I remember doing a demo of Wonderware on Windows 2.0 for my manager in the Salesforce. I reported after tech support. I was on a project working for the national sales manager for HMI. And I sat down and loaded and built a Wonderware system in front of them and hooked it up to a GE Series 6 PLC, and then just went,
Yeah.
Well, remember, one of the problems too with drivers then in the DOS apps is they were inside the HMI. They were not independent. So unless your HMI had the ability to have a network and sharing of a common database, and remember, Ethernet as we know it today, folks, was not a thing in 1990, at least in industry. It was not. You could end up with multiple HMI stations talking to the same PLC. Oh yeah, Data Highway Plus was the fastest we had, that and Modbus Plus. So you end up with bottlenecks, a lot of performance issues, coordination headaches, because that was state of the art. And some of them, if you made a change, depending on how that HMI worked, you might have to restart the HMI for the change to take effect.
Yeah.
Hey, it was state of the art. It was what we had. But Wonderware and Involution, because they were not captive to a hardware manufacturer, they had no choice but to get a lot of drivers. None at all. If they wanted to eat, they wanted to survive, they had to communicate. But they also were startups with limited capital. So they took a page out of the Bill Gates book that many companies have, that if you want to be a successful platform, you better make toolkits, you better make it easy, you better even be willing to help other people write products for your platform, aka drivers. Wonderware did that with their original toolkits, so did Involution. You had distributors like in the oil and gas patch writing drivers for Weatherford, Lufkin, all Epic, Baker, all these vertical specific things, because they couldn't sell Wonderware if they couldn't talk to that. So it was a whole new world. It was like a tectonic shift that was starting to happen in the early 90s.
And the other interesting point about what Wonderware did, because I don't believe that was a chargeable anything. They created the drive because they would sell product because of it. And companies like Rockwell said, well, we have this technology. Well, we'll license it. And so you got this technology transfer agreement between other vendors. They had the information that they needed to create drivers for either for their product to connect to Rockwell devices. And I don't think it was all that cheap either at the time.
No, well, my experience was if somebody wanted to hook the HMI I was selling to somebody else's software, the software to software exchange model, it was about 20 grand each for a C toolkit. And then you got to hire the guru. So your other options were file transfer, maybe. But the most often thing we all saw was just, let's just hardwire some analog points between the PLCs, outputs to inputs, same with digital. And it was horrible. It was what we had. But I know for me as a young person out of college who'd been working with Windows, man, I was frustrated. It's going, there has to be a better way because I've worked in the IT world in college. So I'm sitting there going, well, why can't we use all these great things?
Mm-hmm.
Well, we'll
And
keep
so
going. We know
I,
it came because we know where we are today.
Yeah.
well, isn't that interesting how everybody that's in the business today just assumed that everything just happened? And I
Took a
keep
lot of
on
work on a
telling the
lot of
story of writing
smart
a program
people.
for the DB module on the T3.
I was waiting for that.
God, ASCII basic modules.
And storing it on a cassette recorder. It's like,
Yeah.
you guys have no idea what you've got at the end of your fingers these days.
Yeah. It's amazing where we are now. So,
Oh, it really is.
So Leader Shawn, is it time we start talking about how we got to where
Well, I
we
think
are?
that, Jeremy, would you agree
we
that's a great
created
piece
the
of?
market?
Yeah.
For
I mean, there was a need for it. There was a need for
we
something.
created the
Well, and
need
there's a
for it.
chicken and the egg problem too. Who's coming first?
Well, I think that
for
what
market.
Johnny was talking about, the data that SCADA platforms and HMI platforms required, but there was a lot more people trying to create the ability to be on these communication protocols and communication networks, which required more drivers. Like even a Hardy weight controller, you could throw onto Modbus, RS-485.
Well, and I think the question for John is, how did OPC come about? Like, how did we take order from this chaos that we just explained?
Yes.
Well, there's this is like economists. You ask 10 people who are around, you'll probably get 10 answers. But what I experienced was that Wonderware is out there having phenomenal success. I actually had the pleasure of getting to sell it when GE did a brand label. It was awesome. It's so much fun. And because they were grabbing so much market share, and everybody has this driver problem, and I wish we were a charter member of the foundation, meaning we joined the first year they existed. We were not a founding member, but it's my understanding the founding members got together and said, look, we've got to solve this problem. People are starting to use Windows is in the server room now. IT is embracing it. We have to embrace Windows. The current state-of-the-art technology for sharing data then was a thing called DDE, Dynamic Data Exchange. DDE was around, guys, in 98. Somewhere I have a VCR cassette, but you can find it on YouTube, called The Soul of the New Machine. And it's a Microsoft video about Windows. And they show taking an Excel graph and exchanging data with Word. And then they came out with this thing called OLE, where you could embed that graph into your Word doc. And whenever you edited Excel, save, close, open Word, your graph would just update automatically. Or if it happened live, it would do it. 1994, 93, 93, you could do that. It was amazing. Wonderware had adopted DDE as their method, but they had to partner with Microsoft. They partnered with Microsoft because DDE had some problems. Not very secure, one data point at a time. Wonderful for office applications, not so great for the plant floor. So they created this thing called Fast DDE that, hold your breath, everybody, hold your breath. It lets you put lots of data points in a single request, read or write. And then they created this thing called Net DDE. Oh, you could do it over the network. Amazing. Okay. So that created a decoupling of the driver from the HMI. So printer drivers for PLCs. That's what it was. And this market for people creating DDE servers emerged. You mentioned Kepware, one of our longest partners. They had an HMI long, long time ago. They don't anymore. Most people on this watching don't even know that. Called Kep HMI. They had a bunch of great drivers. They ripped them out and made DDE servers out of them. That's how Kepware got going. Okay. So all of a sudden you had specialist gurus, as you mentioned, creating things, and it's classic economic specialization. Everybody does what they do best. But because DDE still had performance issues, NetDDE wasn't very reliable, there were no standards of how you exchange data, and all you got was a value. There was no discovery mechanism. You had to know. You had to go to the PLC
Mhm.
person,
Yeah.
get the tag list, and you had to go configure your driver and hope the tag list was right. And if you weren't also the PLC person and it was wrong, one of my drawings I use when I train our people is I show gears with these sparking rusty gears because it was a lot of friction in the marketplace, but it was better
Mhm.
than what we had. There was no timestamp. You couldn't tell when the value last updated. You had no quality, meaning you get a value from the DDE server. Well, is that a cached value, or
Mhm.
when's the last time I'd actually talked to the controller? So for all of its greatnesses, they were missing. And those vendors got together and said, all right, there has to be a better way. And that was OPC.
Mhm.
OPC stood for OLE for process control, using the Microsoft technology name, OLE for process control. Guilty as charged, one, a bunch of engineers would get together, name a standard. What do? We fill it with techie terms.
Yeah.
Since evolved, OPC stands, I think, for Open Productive Connectivity now. I need to be careful. Stefan Hoppen will shoot me if I get it wrong, but
Mhm.
that's how it got started, is vendors needing to solve a problem. And oh yeah, users. Okay, I've been sitting here talking about vendors. Let's stop here. The most important part of all this is you users, integrators, and machinery OEMs. I was living it. You all,
Mhm.
because of what you could get from Wonderware and Intellution, particularly Wonderware, you were demanding, as you should, the right and opportunity to choose best of breed software.
Yeah.
No
Mhm.
more of this. I have to buy the full stack from one vendor. I want to buy the best drivers. I want the best HMI, maybe the best historian, and I'm going to use a different alarming package. And I want them all to come together and work because that's how it is on Windows.
Mhm.
So I think most of all, the user demand created the market to say to all the technology vendors, open up, start sharing,
Mhm.
because we're going to buy from those who do. So there you have the demand. OPC became an enabler for the supply.
Mhm.
I don't know that I would have founded Software Toolbox without OPC. Because to write a software product with different interfaces upstream to 6 HMIs and make money,
Mhm.
it
Oh.
was, you couldn't do it.
Mhm.
So it became the enabling technology to then fill the demand. And that's my belief and story on how it got going.
Mhm.
And
I,
God,
oh, sorry, Sean. I did a little bit of research, and I think I got it's a PDF,
Okay.
and the PDF was something about the history of OPC, and they talked about the task force
Mm-hmm.
and the people on the task force. And it's kind of interesting that there were three guys from Intellution on it.
Yeah.
wow.
And it's kind of like, well, why not? Why they would want this? Because of the when I was working with Teledenken, part of the biggest problem that we had was the creation and supporting of drivers because of firmware changes that happened and that was pretty narrow. So
Yeah.
you imagine having 150 drivers under DOS, if you will, or even under Windows. The
Nightmare.
support requirements of that and the ever-changing landscape, you would
Yeah.
want to have some level of standardization. I was just really interested in the fact that there were three guys from Intellution there.
Yeah. Well, and that
No,
task force was all volunteer. They did
Mhm.
it. Yeah. The companies, of course, who were employing them contributed.
Mhm.
But this was also during the hardware field bus wars, and I
Yeah.
know I had been in the industry long enough by then to go, okay, is this standard going to work? Are they going to actually agree? And they
Mhm.
did, but it was volunteer, and they made it. Now it's an IEC standard even, but even
Mhm.
then it was a nonprofit, independent. Yes, certain vendors, as they always do, had influence. They invested more people. But what I experienced as a young person in this industry was, oh my gosh, they're actually getting along. They're actually solving a problem.
Mhm.
Wow. Okay,
Mhm.
this is more like it. Sean,
well,
you raised your hand, Sean.
Yeah, I was going to say, the necessity is the mother of invention, right?
Yes,
So
sir.
you have InTouch just knocking it out of the park with their huge suite of drivers that they invested in,
It
and
worked
so
really
these
well.
other that worked really well, and that was like one of their ways to maintain market dominance. And like you said, every time I saw it, it looked awesome. But you're looking at this and you're saying everybody else is like, we got to do something about this. They create this standard to try to alleviate this pain point, right, for all of them,
Mhm.
right? And I just find it so interesting that InTouch is one of the last people to jump on board with it because they really didn't need it, right? They already had the market presence. They had a great suite of drivers. Everybody
Mhm.
else is like, this is going to fill that hole that we have. And you were telling that story, and I just thought it was so interesting that
Yeah.
really didn't need it. So they were one of the last people to adopt it.
Yeah, and they did. And I tell you, when they did adopt, they became supportive. They hosted one of the second ever OPC interoperability workshop. Picture 30 of us geeks in the room, network laid out on the floor, Windows domain controller server. We all join and we all test our OPC clients and servers. They hosted the second ever one in Lake Forest. So they came on board, they supported. And the thing to remember is and I think part of it is two things. A, market demand. They've always been a market responsive company.
Sure.
But it was also the second problem that OPC solved. OPC wasn't just printer drivers to talk to PLCs, drives, control hardware. All of a sudden, it solved the problem of software to software.
Mhm.
Because your HMI could be an OPC server and present its tag database over here for this machine over here as an OPC client to consume tags. So, the hey, my plant is all fill in the blank HMI, but you get one OEM machine in and it's different because the OEM was going to upcharge you to change. And now you need to integrate that into your whole SCADA system.
Mhm.
That was a nightmare before. You just had to wire up the PLC. That
Mhm.
also started driving demand. Do
Mhm.
you support OPC? Was the question. And like I said, they've jumped on board, and I know they're using UA now. So interesting history.
Mhm.
Yeah, Jeremy, I want to throw it to you to see if you have any questions, and then I'd like to
Yeah.
talk a little bit about the different versions of OPC because that can be very confusing, right? But
Hey, oh
Jeremy, let me
boy,
throw it
is
to
it.
you.
Just caught it. I found that the use of OPC and John and I have when I was through my writing, I did some software reviews on some of the software that they created and marketed, and using Visual Studio to create your own product
Oh yeah,
task or that's
that
and
was an
it was
era.
amazing, just amazing the stuff that you could do.
Yeah.
Whereas in it before, because it was so closed and proprietary, you had to have this technology transfer agreement license and so on and so forth.
Yep.
But the ability now of OPC and they sort of have a bit of an open interface, or the product that interfaces with X has an open interface.
Right.
Now you've got 10,000 different programmers out there using Visual Studio, or 100,000 or a million,
Yeah.
that have access to your hardware through this thing called OPC. And now all of a sudden, like Ed Stern with Canary Labs,
Yeah.
it's like, wow. And he is, I don't know, it's been at least 25 years for his trending packages and stuff.
Company
And
just turned
he's
40 last year.
really,
Yeah.
oh, geez, man. I know that
Yeah.
he was part of the DOS based stuff too, but
Sure.
Uh, but having a niche company that has survived that long because it's consuming data typically through OPC.
Yeah.
You
I want
know,
to throw out another observation too, and
Sure.
both of you chime in on this.
Okay.
It seems like there was something in the air at that time. Because if you think about the early to mid 90s, there was something else that was happening that was pretty big, right? And it was called
Microsoft.
no, well, Windows 95. We've talked about
Yeah.
that. How the installed base just went through the roof, right? I mean,
Yeah.
I posted this week. I was like one of the guys in line for my copy the day it came out, but I digress. Common Industrial Protocol which
Mhm.
gave us Ethernet IP, which is now,
Right.
tied with Profinet for being the most installed field bus out there, right?
Sure.
But that bridges seamless routing and bridging between DeviceNet, ControlNet, and Ethernet, that was all happening. It was open, right? It
Yeah.
was, Ethernet IP was always open. DeviceNet was always open. ControlNet took a little while, but it almost seems like there was something in the air in those 90s that, hey, let's do open networks. Let's do
Yeah.
open OPC. And I mean,
Yeah.
do you guys see that too? Or
Lived
Mhm.
it. Lived it. Loved it. You know, Jeremy, you
Mhm.
talk about the VB people writing HMI. That was another genesis of me creating this company was I had some customers who wouldn't buy even the cheapest InTouch license from me. And they said, well, check out this thing I made for my manager. And they wrote it in Visual Basic 4 using some things called
I
VBX
have it.
controls.
Yeah.
And I'm going, wait a minute, this is the competition? And while we waited for OPC to get going, that's how we made money. We were
Mhm.
selling ActiveX controls, selling components, visualization drivers, whatever, until
Mhm.
OPC took hold. It's
Yeah.
wild. So you're right. There was something
VB4,
in the air,
RS
something in the
tools.
water. I
Yeah.
think it was just the spirit of the time. Then mid-90s, the open internet comes, and all of a sudden, you could exchange things with people on the other side of the world in seconds.
Well, that's it too, right?
There's a bit
The
of a
internet,
demand
It was
right?
there.
just
Indeed, and
a
it's
lot of
kind of
fun.
like the data is there. I want it.
Right.
Like,
And that changed the
how do I
mindset.
get it? You
I
know?
want it all. I want it now.
Yeah, and there's got to be a way to do it. And say ActiveX was huge.
Yeah.
And
When it
Mark
was,
McCary
yeah.
of automated controls, automated systems. I can't remember the name of his company. He created all kinds of ActiveX controls, and they were damn good and damn easy
Oh,
to use.
you're talking about left ACS, Chuck Kowalski with InGear.
Hey guys, I'm just breaking in here. I hope you're enjoying this week's show. I just wanted to remind you that we're asking you to vote with your wallets. If you want to see us keep giving up our Sundays to do this, we'd be happy to. We love doing it. We got some great people lined up for 2026. But we're going to need you to vote to let us know that you want us to do that. And the way you vote is you go to givesendgo.com/automation museum and you make a $5, $10, or $20 donation. If we can get up to, I think it's like $800 to actually file the paperwork for the nonprofit, we'll try to do it ourselves and to save money if that's all we can raise. Then yeah, we'll keep it going in 2026. We actually have some great guests lined up for the show, but we need you to vote. We need you to vote and let us know you want us to continue doing it, and because we love doing it, but we just want to make sure we're spending our time someplace where people think it's valuable. So again, if you want to see the History of Automation podcast and show continue to go, if you'd like to see the Automation Museum become a reality, please visit givesendgo.com/automation museum and place your vote with a $5, $10, or $20 donation. And we appreciate it. We appreciate it. And again, we'll continue to bring you this show if you think this is something valuable. In any case, I do want to wish you all good health and happiness. And now we'll return to the rest of this week's episode of the History of Automation podcast and show.
Really?
Yeah, is that who you're talking about? Because he had a lot in the InGear ActiveX controls. We worked with those a lot.
No, it was Mark Markarian was the guy's name.
Okay.
Automated Solutions, that's what it is.
Oh, Automated Solutions. Yeah. The early
Yeah,
AutoSol.
California.
Yeah. What became AutoSol. Yeah.
Yeah.
You had them, you had InGear, and you had another company in Houston called Parajack Controlware. They were the three.
Parajet. Yes, indeed. Yes.
We actually got trained on VB4 by Rockwell because they were selling RS tools. They didn't know, is this VB thing going to take off? I loved it. I loved, having grown up with BASIC, using VB4, and the box was, I'm telling you, the box came with manuals. It was the biggest software box I ever got. Almost the size
But it
of
was
a PLC
open.
It
You
was
could
totally
just
open,
do it.
easy to use. And when you buy an ActiveX suite, you got your gauges and your inputs and, with all the things you wanted, right? So it did threaten the HMI market, the SCADA market for a while, but I just think people realize that these companies have put, hundreds and thousands of hours into their products, and, it's never going to be as
You
easy
hit a
to screw up.
ceiling. You hit a ceiling where you don't need to be writing code anymore. We created some of our a product once because we got sick of people buying development tools, underestimating what it would take, and then wanting support. So we would sit there and go, okay, let's go create an off-the-shelf application that meets that kind of core functionality level that they need, and at a price point and say, look,
Yeah.
this isn't going to be fill in the blank big thing ever. So if that's your vision, understand you will hit a ceiling and maybe you should go invest in that. Because but there are a lot of I'll call them, shade tree mechanics. And hey, I respect the heck out of them. They're pioneers in this space too. But there are a lot of shade tree developers that eventually realize, and they moved on. And they moved on.
I think some of the resistance perhaps was the license cost of some of the SCADA guys. Like $10,000-$12,000.
Well, and it went both ways.
Yeah.
There was resistance to the cost of the run. I hate runtime fees. That was the mantra of the early 90s. But then one of the resistances among in OPC adoption was people who had gotten used to the Visual Basic model where you buy the toolkit and maybe you paid maintenance for it. That wasn't even very popular then. And you could just write applications and distribute them. No runtime fees. As a vendor, it wasn't a very great business model. I don't mind putting that in the history books because we evolved and thrived otherwise.
Well, if you don't mind, I would love to take a look at what. So OPC is created. People start using it. It allows an OPC server to talk. You can buy an off-the-shelf OPC server suite that has every driver you ever want. The vendor doesn't have to maintain it. A third party maintains it. And then the SCADA people, HMI people can just be happy on their own. They can embed licenses in their HMIs. And there's somebody there. There's probably 4 or 5 big vendors making OPC driver suites. And they're responsible for it. And the vendors can bundle it or you can buy it separately. And that seemed to solve a lot of issues. But there was a lot of deficiencies in what I think they call the original OPC now DA. So you can take us through why the original OPC did not last forever. I mean, some people still use it today, right? But can you take us through like why there was a UA and an A&E and an HDA? Can you talk to us a little bit about that?
Yeah. So let's talk about DA. Data access was what we've all been talking about. Get me the data. Who's getting real-time data, single points with value and quality. Okay. Well, let's talk about the proliferation of the sister standards first, then we'll talk about the evolution, why it had to move forward. Okay. The next problem that had to be solved was what's called HDA or historical data access. And this created a lot of confusion because everybody thought, oh, you're storing your data in HDA format. But the problem that was actually being solved was historians that were storing data in proprietary data stores. Maybe it's going in a SQL table, but it's being compressed and stuff done to it, or proprietary binary files to get the speed needed for process historians. Well, those companies all wanted to differentiate. So they all had their own tools to extract the data and view it because they wanted you to use their tools because their tools were better. You also had DCS systems, which of course, that's full stack, top to bottom process control, very critical stuff, needs to be that way for reasons at the time, good reasons. They were also storing data and they didn't want to let anybody else share it. So OPC HDA was about saying, all right, let's provide a way for people to write drivers that can access data from those historians and then deliver it in standardized record set formats. And while we're at it, maybe allow the OPC server to do average, min, max, do some things to add value to that data. So now anybody's tool can go look at that historical data. You look at people like Canary. All of a sudden, you want to use TrendLink, use it with OPC, HDA to pull the historical data. You don't have to just be a DA that's then logging the data. So to sum up, HDA, and to this day, the historical portion of OPC UA does not define how the data is stored. It defines how it's shared. That's kind of a key thing for our audience to remember. It's how it's shared. The next problem was alarms. Same problem. Specialist systems managing alarm data, particularly DCS systems, don't want to share it with anybody else. I'm not putting them down. They have their reasons. For our audience that wasn't there, maybe is watching this, a DCS vendor typically would take top to bottom responsibility and liability for that system. Well, as a business owner, I can tell you, you don't take liability for something you don't control.
Right.
You can take liability for what you can control. Your people, your partners, that's it.
Mm-hmm.
And you're talking about stuff that could go boom and blow up cities, kill lots of people. Yeah, so that world existed, still does today, but it's evolved. Probably a topic for another show. So you got all these alarms. Same issue, though. How do I get the alarms out? How do I pull together and aggregate alarms and share it in a data structure that's standardized? What's the tag? What's the alarm value? What was the alarm limit? When did it go into alarm? Provide a standardized way to acknowledge the alarm, clear the alarm, standardized ways to share the data. Those were the three that got going. There were others out there, XMLDA, which I briefly will mention, because it was an attempt to solve the problem with DCOM, which, I don't know, DCOM maybe became worse than NetDDE. But there was also an attempt at OPC DX, which was PLC talking to each other. There was an attempt at a complex data spec. There was a command spec, which was like firing methods. Think like a database transaction. Write this into like a buffer, and then fire the command. Do it all at once. There was an OPC security spec. Thing is, the foundation steering committees were smart. They realized, wait a minute. We're proliferating all these standards. Developers, this is not efficient. There's got to be a way to have a more common stack of OPC code, and then you implement profiles of what you need. Because otherwise it's going to become too inefficient to develop the things the users wanted, and the standard would not succeed. So they got ahead of it. XMLDA was a way to exchange data over HTTP in an XML data structure. Not real fast, but it worked. I'll pause, but I am ready to move on to the dirty word called DCOM.
I'm good for DCOM. I'm good for DCOM. People
nobody
should
was
know.
ever good for DCOM.
There was this moment in our history where people were told, if you're still using DDE or the older OPC, it's going to stop working because DCOM has a vulnerability and Microsoft is killing it. And there was a lot of panic.
A couple of years ago.
A lot of panic. There was a lot of tech notes, and those people who let their systems upgrade. Yeah. So go ahead. Let me turn it back to you. Yeah.
Yeah. So, I talked about NetDDE being, we could do it over a network. Well, at the time the OPC was started, there was COM, Component Object Model. That was the standard Microsoft way for apps to share data. Then there was COM Plus for, I don't know, a year or so. That was adding the ability to do it over network. And then they called it DCOM, Distributed COM, where computer A, computer B could talk, security, handshake, all that. Revolutionary at the time, okay? And OPC jumped on that as a way to have an OPC server sitting here on a computer and HMI stations up here all talking to that single OPC server. And it worked until it didn't. And I'm not talking 2023 when they hardened it and shut it down. I'll tell this story because I think most people need to know it. I was in a room in Redmond with some of the early adopters of OPC in August 97 with a conversation with product managers about two things in DCOM that were frustrating to us in the OT world. The timeout, hey, Jeremy, go read this.
Yeah. Hang on, I'll be right there.
Yeah. And normally I should have a timeout at which point I go, Jeremy went and just must have seen something great on TV or fallen asleep. I give up and I go again. There was a 6-minute hard-coded timeout in DCOM. Could not be changed as of 97.
Wow.
The other thing is, Jeremy, I couldn't cancel my call. I couldn't say, I'm giving up on you. I have to wait for the timeout. Now, I'm going to get real nerdy on you both here, but back then a lot of applications were single-threaded.
Oh, yeah.
And so that was a blocking call, which means I couldn't do anything else, including update my screen, until I could cancel the call or it timed out. Symptom for you users, my HMI screen just locked up because IT rebooted the network switch. I went and yelled at, you go yell at IT, they go, what's the problem? It was a switch reboot. It took a minute. A minute? You just took the whole process line down. Well, it wasn't a problem in the office. Well, that's the office.
Yeah.
Those were the fatal flaws in decom.
Mhm.
Unfortunately, they never got resolved. So you
Interesting.
had a whole breed of products come out
Mhm.
called tunnelers. Matricon had one. Cogent Real-Time Systems had the Data Hub, which is one we were very successful with, that
Mhm.
would sit there with a piece of middleware at the client and the server, and in between we'd talk TCP/IP, we'd have a heartbeat, we could cancel the call, we could figure the timeout. I used to do demos with Data Hub, tunneling from Perth, Australia to Charlotte, North Carolina to a server, and I'd kill my jetpack, and I'd turn my jetpack back on, and the network would recover. Anybody using decom just went, but that's that and the need to make development simpler to simplify the problem set of OPC development while at the same time expanding UA to recognize that every point is a node that could have real-time data, historical data, alarms, all these other things associated with it. Because UA has a TCP/IP stack. It has all the great things you need to be able to cancel those calls. So, and yeah, Microsoft eventually killed decom, and I know my support team and we were thrilled.
And there was a lot of problems with, I think, when Microsoft introduced their Windows firewall, because you had to run
Yes.
decom
Oh,
through the
no
firewall. And so
way
there
you're
was
going to get decom
tech
through a
notes,
firewall.
so
You
many
had to,
tech notes, disable the firewall, disable this, disable that.
you could tunnelers. That's why there was a big business in tunneling software for a while. Not so much anymore because people are using UA, and that's great. It's fine. You know.
So what was you have all these problems with OPC or
Yeah.
OPC-DA, as we now call it.
Yeah.
And so I guess the band gets back together and says, we got to do something new and different.
Technical steering committee got back together around well, they never disbanded, but they hadn't been doing a whole lot, but they got back together in kind of, I think, 02, 03 area. And I think between 06, well, it was around 08 or 09. I was at the press conference with Tom Burke for the release of the first OPC UA spec in Boston. But the steering committee got back together and said, all right, let's take everything we've learned over the last decade. Let's look at the available technology stacks now, and let's reimagine ourselves. These old standards I've just been talking about are now called OPC Classic. Look, if you're not using decom and your client and server on the same machine, they still work, but you need to move to UA. Because they also said, we got to address modern security.
Mhm.
There's modern security needs. And yeah, you never run decom through a firewall, ever. We wouldn't support it. I told people no. You have to open too many ports. I don't want to be responsible for advising you to open those kind of ports in your firewall. No way. It's irresponsible.
Mhm.
So UA gets born in 2009. Wonderful. Here comes the Great Recession. Who has time to invest? But boy, our foundation done a great job with all the magazines of telling everybody you needed UA. So all of us went and developed UA interfaces that didn't really start getting used till about 2011, 12.
Yeah.
But you had to have it or people
Yeah.
wouldn't buy your product. So,
And you had to have something from them to move to if they ran into that problem with decom.
Right.
Yeah.
right. Oh, yeah. Big business in gateways. There's still a good business in gateways.
Mhm.
Several of us out there in the market offer versions of gateways. You just drop them in, DA to UA converters. Think of it, USB-A to USB-C converters.
Mhm.
So,
No, absolutely. And there's a lot of third parties that are creating gateways for just about anything because of the
anything.
availability of OPC and the
Yeah.
sort of the APIs and the connectivity part
Yep.
of it all.
Yep. So, where you want to go from there, Shawn? Because if I'm not careful, I'm watching the clock. I know how long I want to bore our audience with all these stories.
I think it's all very, very interesting. And I'm like,
Yeah.
I don't want to go too much into the future, but I do think we're in for another evolution of OPC. But this is the History of Automation podcast, so you should probably save that for some other
Yeah, well, we could
venue.
go to, the OPC UA's evolved. There's OPC UA pub sub. There's OPC UA companion specs for vertical industries. Happy to join in a conversation on that one and where it's gone, but because we're living it, we offer products and but there's other standards coming around too. You've got things like MQTT, which is a transport,
Absolutely.
and OPC and their pub sub can write on top of MQTT.
Mhm.
People say OPC or MQTT. It's like, and depending on what you're doing.
Yeah.
But we'll leave that out there as interesting things people might want to come back to learn more about on the Automation History Podcast.
Understood.
Yeah, and I'm wondering, Jeremy, anything else historically wise, from the 80s through 90s, early 2000s, that we should ask John while we have him here about OPC and related topics?
Yes. I think that with the advent of standards, just generally speaking, and it's mine and I want it now, does OPC UA as it sits solve all of the problems that people could imagine in present day?
There's Jeremy the journalist. I love it. OPC UA solves a lot of problems. No standard solves 100% of the problems because every user's application needs are different. Okay. There is absolutely a lot of convergence happening in the market. Things are moving faster. Technology adoption's faster. Absolutely. That's different than when we started with this. But, people would often ask me at Software Toolbox, why do you have 3 products that appear to do the same thing? Well, because everybody's problems are different price points, different functional needs, etc. I'm here to help solve problems. Standards are the same way. So, I want to support you as a journalist, but I'm not going to wander into making statements that I end up getting the chairperson of the OPC Foundation coming at me or people with MQTC and their standards coming at me, because my thing is for users, my job's not to pick the best standards. My job's to help you interoperate and get your data.
So from what I hear you saying, John, is the fact that we still need to have a multitude of solutions. Like we need OPC UA revision 1, 2, 3, 4, 5 for different
It needs to
areas
evolve,
of the
and it is
business or
evolving.
of the OT world.
Yeah.
And it will evolve for things that we don't even know we need yet.
Right. And I will say the steering committee did a good job with the foundational piece so that can happen more readily. I do want to address one thing about OPC, if I may, guys.
Please.
Certainly.
Sometimes there's a misnomer out there that OPC is 1,500 pages of specs. That's true. Happy to print them out, but I really like trees. I'm a camper and hiker. So you can print them out. Yes, if you want to implement every part of the OPC UA standard, it's a beast. First to admit it, there are other standards that are shorter. Here's the analogy, though. If you go to an American style, you go to a restaurant that, typically owned by a bunch of Greeks here in Charlotte, they got every type of food you could ask for on there because they want you to come. If you're hungry, you'll find something. Do you ever go to that restaurant and order everything on the menu? No.
Not even on a good day.
Not even on a good day. So guess what? Nobody implements 100% of OPC UA. They implement what they need. And the foundation knows that. So, I think we just have to be careful when we make comparisons. Are some other protocols maybe simpler? Yes. But, there's also a whole lot of things around security. I could go on. There's a whole conversation there. I just want to wrap myself again by repeating, I'm not here to pick winners. I'm here to solve problems.
Right.
Because that's what our users want. They want us people who can look at a problem, discuss it in the context of their needs, their budget, their growth plans, and make reasonable recommendations based off of fact, because we're engineers.
No.
And I'm glad you asked it, Jeremy. Thank you.
You're welcome.
Love you, man.
And it's the thing, having grown up with the disparity in hardware, the no, you can't get there from here. sort of mindsets from the early days, the ability and the historical run that our communication platforms have had, gives everybody the ability to somewhere, somehow, at some time, get what they want when
Best
they
of breed.
want. It does.
Best of
Is
breed
that
for your need. Hey, that rhymes.
okay?
Shawn?
It does. So
Let's get
OPC
somebody
is
to put a rap
really
song together to that. Best of breed for your need.
Well, guys, I'm looking at the time. We just
Yeah,
have
we need to wrap up.
we just have a few minutes left. One of the reasons why people needed these driver suites was because there were so many different industrial networks. We had
And there
in
still
'79,
are.
I think, we had Modbus and we had Data Highway, and it just multiplied from there in the '80s. And so, you got Profinet, you got Ethernet IP, you got EtherCAT, you got all the legacy Modbus TCP, you got all the legacy networks as well. It seems like you guys, when you guys talk about the field bus wars, right?
Oh.
When you say that, and we only got about 10 minutes left, but
Yeah.
just tell me, what do you guys, what's your, like, your angle to that when you're seeing field bus wars, right? What does that
Well,
mean to you, John?
well, back then it meant all these different hardware vendors with competing standards, all of them trying to be the one to win, but not getting enough people on board of it. Now, this is interesting you bring this up because OPC is working on this with a thing called OPC TSN, time synchronous networking, and technologies now that to have a version of OPC UA that's very hardware based to be that real time field bus and try to leverage that. Standard's only as good as the number of adopters you get. And the field buses, Profinet, Profibus aside, I feel like they probably got the most, but you may know more about this than me, Jeremy.
Well, I'm just remembering Field Bus Foundation, and they're pounding the table. You gotta go with this standard. But if you went with that standard, everybody else was off the menu.
Yeah.
Right.
And I think that was the whole war thing, is that you had to choose. It's kind of like having 5 girlfriends, and you got to choose one.
Well, at that point, is it really a standard?
Yeah.
If
No,
it
it was
forces you to make choices for best of breed, then it
Yes.
really isn't a well-adopted standard.
True enough.
And I think that's where
you had to make that choice, though.
Right.
You
But
had
users
to
don't want,
pick
they don't
a
want to
fight.
have to do that.
Well, I don't.
and that was a
disagree.
reason. That was the reason why you stuck with one vendor. I got Allen
Yeah.
Bradley because everything talks Data Highway. I got Modbus. I got Modicon. Everything talks Modbus. Or I'm
Yeah.
a third-party vendor and I support both, or I do Profinet.
Yeah.
But you chose your vendor by your installed base networks. And it just seems the genius of Ethernet. I mean, looking back today, is once we had Modbus TCP, Ethernet IP, and Profinet, it's like, oh, do you know they can all live on the same wire now? It kind of.
Were any of you at the ARC conference, and it was either 99 or 2000, where General Motors gave a presentation that showed how Ethernet over 100 meg switches, not hubs, was as or more deterministic than Data Highway Plus?
No.
I was in the room for that. That was an inflection point in our space for the use and adoption of Ethernet.
Yeah,
Data Highway Plus being token passing, I'm not sure you could say it was deterministic at any point.
Well, deterministic being defined as predictable, repeatable.
We used to go to Rockwell, and we used to
within
Yeah.
Go ahead. I mean, when we would go to Rockwell and go into the lab, we would see how much data we could pump over ControlNet and Ethernet.
Yeah.
ControlNet 5 meg, Ethernet 100 meg, and they were literally about the same amount of throughput. But Ethernet was built into every laptop. Ethernet was built into every computer.
Ubiquitous.
Who cares 5 or 100 if they pump the same amount of data? Yes, and
the switch
handled
the switch handled the collisions issue too.
Yeah.
That same presentation, GM showed that with just a hub, because Ethernet is back off, retry, the switch got rid of that. There is no back off and retry, so that you could, as you went up to the capacity of that network, your throughput didn't tail off like it would in a hub because you had too many collisions.
Right.
I know I'm geeking out for people who don't care about this anymore, but appreciate
I
what we
appreciate-
have in the ubiquity of gigabit Ethernet in our
Yes.
laptops.
Part
Well,
of the reason why we're doing what we're doing, John, is to give people the understanding that it wasn't as easy as it is now. And again, we didn't have switches back in the day. All we had was hubs,
They were
and we had that
expensive.
lack of determination, you know.
Yeah. Well, and
It was
I want
never
us
as
to
easy.
inspire this next generation too. You take what we have now, and man, I want to be around long enough on this earth to see the amazing things you're going to do
Yeah.
that we can't imagine now.
Mm-hmm.
I think it's going to be amazing.
It will be.
Yeah, and I want to thank you both for coming on the show, and Jeremy, of course, co-host. But John, we'd love to have you back. If there's another topic you'd like to talk about old stuff, the history of automation, we'd love to have you back. I want to ask all the viewers, go check out the interview I did with his folks over at the Automation Podcast. I thought it was awesome. And
Yeah.
I will give.
They'll show you some cool new stuff, by the way.
Yes, cool new stuff.
Very
yes.
cutting edge.
Yeah.
So with that, Jeremy, I'm going to give you, let me turn it to you, and then you turn it over to John for the final word, and then we'll close out the show.
I was a product manager for Teledenkin back in 1988. And I can tell you that the headaches, the main pain points, as Shawn likes to call them, was drivers and the overlays and I wasn't doing any programming as such, if you will. But the guys that were doing the programming and the overlays that had to happen in the DOS environment, people will, you'd pull your freaking hair out trying to make things happen. The advent of Windows created the availability of a different level of technology. And whoever had the mindset to say, we need to have some level of standardized communication for data access and for equipment access, got to take your hat off to them. It was one of those things where it's like, well, it's not there yet. So let's create it. And those pioneers, we have to take our hat off to. And to John and Software Toolbox for grabbing onto that at such an early point in time, having the faith in it to take it to where it is today. Thank you, John.
Thank you, Jeremy. Thank you, Shawn. Happy to be here. Happy to share. I just remind people just like these guys, I've seen a lot of technologies come, go, always be open-minded. I don't come on these things to go bash one technology over another, but no technology is ever perfect. Use your critical thinking, be open to different things, different ideas, so that you can use what's out there today, whether it be OPC, MQTT, whatever, Sparkplug, whatever comes along to solve your problems, make the best of your business. And then you go be the next pioneers that sees an unsolved problem. And those of us are here to cheer you around and, connect with me on LinkedIn. I'm also happy to talk with anybody who's got an idea, wants to bounce it off somebody. I'm reaching a point in my life. I want to pay it forward. So thanks, guys. It's a lot of fun, but this football game we need to go watch.
You betcha.
Yeah.
Thank you, Shawnee.
Thank you, John. Thank you, everybody. Until next time. Peace.